Bismillah ar-Rahman ar-Rahim. Assalamu alaikum students. This is Hamza Noor, and today here we have a question. October-November 2019, paper 43, question number 2, Mechanics 9709. The topic is work and energy, uh, work, energy, and power. But in this question specifically, the power is not required. So this is related to work energy equation, the law of conservation of energy. The question says that a train of mass 150,000 kg ascends a straight slope inclined at alpha to the horizontal with a constant driving force of 16,000 Newton. Full stop. We have an inclined plane, a plane which is inclined at an angle alpha to the horizontal. And we have a train over here whose mass is 150,000 kg. So the weight is acting vertically downwards, 150,000 g. And since this angle is alpha, so this angle is also alpha. And the component which is perpendicular to the plane over here is 150,000 g cos alpha, and along the plane is 150,000 g sine alpha. And this is a normal contact force acting perpendicular to the plane. And here we have a constant driving force which is 16,000 Newton. Okay, so at a point A on the slope, the speed of the train is 45 meters per second. Let's say this point is A. At this point, the speed of the train is 45 meters per second. And point B on the slope is 500 meters beyond A. And the train is going upwards, it is ascending. Okay, so B is, let's say, over here. And at point B, the speed is 42 meters per second. And the distance between A and B is 500 meters. Distance between A and B is 500 meters. All right. So here is a resistance force acting on the train, and the train does a work of 4 multiplied by 10 raised to the power 6 joules against the resistance force. So let's say this resistance force, I can call it RS. Now, since I've mentioned this R over here, so I'm taking this as RS. Resistance force, it does a work of 4 multiplied by 10 raised to the power 6 joules, meaning 4 million joules. So when this resistance force is multiplied by a distance of 500 meters, it will give you a work done of 4 multiplied by 10 raised to the power 6 joules, meaning 4 million joules. Okay. And we need to find the value of alpha. So we are just considering the journey from A to B. Okay. What we are going to do, we are going to use the work energy equation, the law of conservation of energy. And if you have watched my earlier videos on work, energy, and power, I always use this approach, the complete equation. The complete equation is mechanical energy at start of the journey is equal to mechanical energy at the end of the journey if there are no external forces. So the mechanical energy is a sum of kinetic energy and potential energy. But if there are external forces, so mechanical energy at start plus work done positively minus work done negatively is equals to mechanical energy at end. So since in this case we are dealing with the external forces, so there are external forces, we are going to use this equation. Mechanical energy is the sum of kinetic and potential energy. So I can write the equation like this. Since we are considering the journey from A till B, so start of the journey is point A and end of the journey is point B. So I can say that kinetic energy at A plus potential energy at A plus work done positively minus work done negatively is equals to kinetic energy at B plus potential energy at B. Here you go. So kinetic energy at point A will be half multiplied by half multiplied by 150,000 multiplied by 45 square plus the potential energy at A. Since we are just considering the journey from A to B, so at point A, we are considering that this is the horizontal level ground. So at this point, the potential energy will be equals to 0. So potential energy at A will be equals to 0. Then we have work done positively, which will be 16,000 Newton multiplied by the distance between A and B. So 16,000 multiplied by 500. 16,000 multiplied by 500. Then we have work done negatively, which is 4 multiplied by 10 raised to the power 6 joules. So 4 million joules. 4 के आगे 6 0 minus 4 million joules. And this whole thing will be equals to kinetic energy at B plus the potential energy at B. What we need to find? We need to find the value of alpha. So I'm just taking another screenshot to make more space over here. This will be equals to kinetic energy at B plus the potential energy at B. At point B, the speed is 42 meter per second. So half multiplied by 150,000 multiplied by 42 square plus the potential energy at B. And for that purpose, we need this height, this vertical height. So since this angle is alpha, this angle is also alpha. Okay. And here we have the height. We need to find the height in terms of alpha. So let's consider this right angle triangle in which we know the hypotenuse length AB is 500 and we need to find this height. I mean, we need to use this height. Alpha is unknown. So height will be 500 multiplied by sine alpha. So the potential energy at point B will be mgh. So I'm just mentioning the potential energy at B over here. Okay, mgh. So 150,000 multiplied by 10. G is 10 and height will be 500 sine alpha. Here you go. You have mentioned this one complete equation over here. We just need to find the value of alpha. Just solve this equation. So first of all, we have 150,000 multiplied by 45 square and then divide by 2. Then add 16,000 times 500 and subtract 4 million joules from it. So minus 4 million. This gives you 155,875, 155,875,000. This is equals to 150,000 multiplied by 42 square and then divided by 2. This gives you 1323, 1323, 000 and then 00. Okay. And then this value will come in terms of sine alpha. So 150,000 multiplied by 10 multiplied by 500. This gives you 75, 000, then a 0. So 75, 000, and then a 0 multiplied by sine alpha. So first of all, make sine alpha the subject of the equation. So you know what you need to do. Sine alpha will be equals to 155,875,000 minus 1323 000 divided by 75 000 and then a 0. This will give you the value of sine alpha. So 155,875,000 minus 1323 000. All right, and then divided by 75 000 and a 0. The value of sine alpha is 0.03143. Sine alpha is equals to 0.03143. So alpha is equals to sine inverse 0.03143. 43. So sine inverse 0.03143 alpha is equal to 1.8. Your alpha angle is 1.8. This is supposed to be your final answer. This question is worth 5 marks.